the maths exhibition. The science of structure, relation and order has evolved from elemental practices of counting, measuring and describing the shapes of the object is called mathematics. Indian mathematics has emerged in the Indian subcontinent from 1200 BC until the end of 18th century. In this classical period, important contributions were made by scholars like Aryabhatta, Brahmagupta, Bhaskara and etc. So by this, we now begin the exhibition.
Good morning, I am Kathy Singh from class 6A and today I have made a model named Maths Export for the Maths exhibition. To make it, we need glue, exercise paper, cardboard and a straw or a long pencil. You can choose anything to make it. Now, let me show you how my model works. We will do a sum of 90 plus 30. So we'll set 90, then plus, then 30 is equal to, it will be 0 here, it will be plus here, 1, 20. You have seen my calculation and you have also seen how my model works. Thank you.
I am Asta Pavit from class 6C. I have made a model on types of angle for the math exhibition. It's a working model. Now I will tell you how this model works. Types of angle. And now I will show you the acute angle for the 62 degree. This one is the acute angle for the 62 degree. Now I will show you right angle for the 90 degree. This is the right angle for the 90 degree. Now I will show you obtuse angle for the 135 degree. This is the obtuse angle for the 135 degree. Now I will show you straight angle for the 180 degree. This is a straight angle for the 180 degree. Now I will show you reflex angle for 240 degree. This is a reflex angle for the 240 degree. Thank you.
My name is Divyanshu. I am from 6th and today I have made a model of geometrical shapes of mathematics. Now let's get started. The first shape is pentagon. Pentagon has 5 sides and 5 vertices. The second shape is square. Square has 4 sides and 4 vertices. The third shape is rectangle. Rectangle has 4 sides and 4 vertices. The fourth shape is trapezium. Trapezium has 4 sides and 4 vertices. Now the fifth shape is circle. Circle doesn't have any vertices and not have any face. It has only a curved face. The sixth one is hexagon. Hexagon has 6 sides and 6 vertices. Now the seventh one is triangle. Triangle has 3 sides and 3 vertices. And the last one and the 8th one is octagon. Octagon has 8 vertices and 8 sides. Now, thank you.
everyone, I'm Varsha from class 10A. Today I'll be explaining my model on types of angles. Before I start, I want to ask you two questions. The first question is, do you know how are angles formed? Angles are formed when two rays meet at a point which is known as vertex, and these rays are known as the arms of the angle. So the next question is, which instrument is used to measure an angle? Yes, you are correct. A protractor is used to measure an angle. This is the center of the protractor. You keep it all the way right here on the angle and measure it. So this angle measures 45 degrees. Now let's start. So the first angle we have is an acute angle. Acute angle measures less than 90 degrees. So this is acute angle. So here it measures 50 degrees as you can see. Next we have right angle. So a right angle exactly measures 90 degrees as you can see here and on the figure. So this is an acute angle and this is a right angle. Now let's move on to the other angle. The next is obtuse angle. So obtuse angle measures more than 90 degrees but less than 180 degrees. As you can see here, it measures 150 degrees as you can see. And this is an obtuse angle. The next angle we have is a straight angle. So a straight angle exactly measures 180 degrees as you can see in the figure. The next one we have a reflex angle. Now reflex angle measures more than 180 degrees but less than 360 degrees. As you can see here, it measures 290 degrees. The last but not the least, we have a complete angle, which is also known as a 360 angle, which exactly measures 360. That is why it is known as a complete angle or a 360 degree angle. So now here I conclude my words and thank you very much.
Hello, I am Rishikesh Verma of class 7A. Today I am going to do a project on the area of a parallelogram. The materials required are a piece of graph paper, a pencil, a scissor, a scale and a few color pencils. Now we will draw a line AE and on which E is a point on the side BC. We will draw AE in such a way that AE is perpendicular to BC. Now we will color both sides of line AE so that we can distinguish between them. Now we will cut on the line AE so that we get two different shapes. Now if we move the yellow piece to the other side, we will find out that it looks like a rectangle. Now we all know that the area of a rectangle is length into breadth. If we measure the sides of this rectangle, we will find the area of it. Now the area of this rectangle will be equal to the area of the previous parallelogram ABCD, because this rectangle has been derived from the previous parallelogram. So therefore, we can conclude that the area of a parallelogram is height into base. This is a very easy way to understand the area of a parallelogram. Do try this fun and interesting activity at home. Thank you and have a great day.
Good morning. My name is Akash Rao from class 7D. I have made a drawing of Aryabhatta with numbers. Aryabhatta, also called Aryabhatta I or Aryabhatta the Elder, born in 476 AD, possibly Ashmaka or Kusumapura, India. Astronomer and the earliest Indian mathematician, whose work and history are available to modern scholars. He is also known as Aryabhatta I or Aryabhatta the Elder, to distinguish him from a 10th century Indian mathematician of the same name. He flourished in Kusumapura, near Patliputra, present-day Patna, then the capital of the Gupta dynasty, where he composed at least two works, Aryabhatiya and now lost, Aryabhatta Siddhanta. Hope you enjoyed this video. Thank you.
I am Ankita Singh from class 8. Today, this is my maths exhibition of chapter square and square roots. In front of you, I have made a model of working model with the squares. I am going to show you the squares of till 80. One square equals to 1. 2 square equals to 4. 3 square equals to 9. 4 square equals to 16. 5 square equals to 25. 6 square equals to 36. 7 square equals to 49. 8 square equals to 64. 9 square equals to 81. 10 square equals to 100. 11 square equals to 121. 12 square equals to 144. 13 square equals to 169. 14 square equals to 196. 15 square equals to 225. 16 square equals to 256. 17 square equals to 289. 18 square equals to 324. And then again 1, because the size of the circle is too small, therefore I can do only 18. And the things we need in this project or the model is a button, a copper wire, a black piece of paper, a white piece of paper and a red pen ink. This is my model of the working model of the maths exhibition. Thank you and have a nice day.
Good morning, ma'am. Myself Aditya Kumar from A3. My roll number is 3. I will explain you about maths model, which is based on algebraic expression. Cardboard, pencil, colorful sheets, white paper and hot glue gun are used in this model. When we rotate the pencil, no squares of numbers will be displayed in the model. Like as 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 25, 6 square is equal to 36, 7 square is equal to 49, 8 square is equal to 64, 9 square is equal to 81, 10 square is equal to 100. Thank you.
Good morning, I'm Milena Dennis of class 8B, and today my math exhibition project is based on the topic types of angles. As we have learned in previous classes, an angle is a geometric figure formed by two rays, sharing a common endpoint called the vertex. The two rays are called the sides of an angle. As you can see in the figure, this is ray 1 and ray 2, sharing a common endpoint called the vertex. Angles are measured in degrees using a protractor, which is the measure of circularity or rotation. There are 6 types of angles, and they are acute angle, right angle, obtuse angle, straight angle, reflex angle, and full rotation. With the help of this working model, we can see that acute angle. An acute angle is lesser than 90 degrees. It is between 0 degrees and 90 degrees. 2. We have right angle. Right angle is exactly 90 degrees. It looks like quarter of a circle. 3. We have obtuse angle. An obtuse angle is more than 90 degrees but lesser than 180 degrees. 4. We have straight angle. A straight angle is exactly 180 degrees. It is a straight line and looks like half a circle. 5th, we have reflex angle. Reflex angle is greater than 180 degrees but lesser than 360 degrees. 6th, we have full rotation. Full rotation is exactly 360 degrees. It looks like a full circle. It is imperative to understand the concept of angles as it is used in our day-to-day lives. Engineers and architects use angles in constructing roads and buildings. Carpenters use angles to make various types of furniture, etc. Therefore, a common understanding of the types of angles is necessary for all. Thank you and have a nice day.
Introduction of mensuration. Measures and weight has older history than the currency. One of the world's oldest civilization, Indus Valley Civilization, were very technologically advanced as for mensuration. The brick used to construct the building have in dimensional proportion 4:2:1. In Indus Valley, a standardized weight system was also used. In that, one weight is equal to 28 grams, that is equal to today's English owns 28.35 grams. Apart from this, historians has also found a measuring ruler that is called Mohenjo-daro ruler. Its one unit is equal to 1.32 inches, and each unit is further divided into 10 equal parts. Mensuration in pre-Vedic and Vedic era. In pre-Vedic period, to fulfill day-to-day needs, types of measurements were used. Like for linear measurements, body parts were used as shown in the picture. Then in the Vedic period and after, measurements were called pranama. And 4 other different types of measurements were used. Books like Vedic Shubha Sutras, Aryabhatiya and Brahmagupta Siddharthan consist chapters of mensuration. Our ancient mathematicians used to work on mensuration in an advanced level, like for astronomical measurements. For example, if we convert Earth's diameter in kilometer as per Aryabhatta and Brahmagupta, then Aryabhatta is 11,701 kilometer and Brahmagupta 12,727 kilometers, and actually 12,742 kilometers. That is very close to the actual diameter and without any modern day telescope. Introduction of mensuration. Measures and weights.
Arithmetic and algebra in ancient India. Contribution in the field of arithmetic and algebra by ancient Indians. In arithmetic and algebra, Indian mathematicians gave an early contribution. In early Vedic period, 3000 years in daily life. Now, what is maths? Maths is defined as the science which deals with logic of shape, quantity and arrangements. During ancient time, Egyptians used maths like geometry and algebra. For example, Euclid's geometry. Maths is a part of our life. We are using it without even realizing. Use of maths in daily life. Well, there's many uses of maths in our daily life. Some of them are cooking, navigation, sports, architecture, nature, banking, shopping, etc. Now, let us go through each one of them deeply. Cooking. For making tea, coffee, milk, etc. we require the knowledge of ratio and proportion. For example, 10 grams of sugar for 100 milliliter of lemonade. Also, for making breakfast, lunch and dinner, we need to know the correct amount of ingredients to be added. For example, a pinch of salt. Navigation. Navigation is mainly based on the practical use of coordinate geometry. We often use coordinate geometry in order to navigate a city. Astronomers and amateurs use sky coordinates to locate objects of interest. GPS has been designed on the basis of coordinate geometry. They use a mathematical process called trilateration. Even Pythagoras theorem is used for two-dimensional navigation of ships. Sports. When we toss in a game, probability is used as there is an equal chance of getting a head or a tail. To make the field of correct measure, we need to have a good knowledge of mensuration. We can compare success and failure rates in a sport by collection of data. Architecture. A water tower and many other structures include so many solid shapes whose volume can be calculated through geometry. Symmetrical and geometrical concepts has been used in the construction of famous monuments like Taj Mahal and Eiffel Tower. Pythagoras theorem is used to measure size for painting a building or to find the shortest distance to a particular place. Nature. A honeycomb is an array of hexagonal cells made of wax produced by worker bees. Hexagon fit together to fill all the available space. Each rabbit pair produces another pair every month, taking 1 month first to mature and giving the sequence 0, 1, 1, 2, 3, 5, 8, 30. It is known as the Fibonacci sequence, which means each number in the sequence is the sum of the previous two numbers. That is, for example, 0 plus 1 is 1 and 1 plus 2 is 2 and 2 plus 3 is 5 and so on. Emerald, when extracted, have a cubical shape. Mountains have conical shapes. Banking and shopping. Mathematics is useful in banking and shopping in the following ways, such as transaction of money, stocks and bonds, EMI loan, interest to be paid to the bank, interest paid on loan, etc. Percentages, addition, subtraction are used to calculate the purchase price. I hope you all
The
enjoyed
system
this.
of Vedic maths is based on the set of sutras, formulas, though these don't need to be learned. The vertically and crosswise formula is a good example. It enables one-line products of any numbers to be found from right to left or left to right. It uses a simple pattern and it is easy to understand why it works. So here is a PPT on Vedic maths. Introduction. What is meant by Vedic maths? The term Vedic came from a Sanskrit word Veda that means knowledge, and Vedic maths is a super collection of sutras to solve math problems in a faster and easy way. What are the benefits of learning Vedic mathematics? You can solve any difficult, time-consuming G problem or ICSE CBSE maths immediately using Vedic math trick. Moreover, just by using Vedic math, you can solve a problem mentally, and that's the beauty of Vedic maths. While you encounter polynomial functions and quadratic sums in a higher classes in CBSE or ICSE board, knowledge of Vedic maths will lead a helping hand to beat the difficulty level of those sums. Who is the father of Vedic maths? Vedic maths simplifies arithmetic operations, and these formulas and concepts have increasingly found acceptance across the world. Vedic math, the ancient method of solving mathematics problems, was later discovered by Shankaracharya Bharati Krishna Tirjati, who is known as the father of Vedic maths. Vedic maths is referred to as the ancient system of Indian mathematics. The discovery, as the name suggests, was made from the Vedas between 1911 and 1918. The core belief lies around the fact the mathematics is based on 16 sutras. It is the ancient system of calculation. There are some of the methods in Vedic maths. Urdhva Triyaghyam, vertically and crosswise method. Shankana Vyavakalanabhyam method. Features of Vedic maths. Chalana Kalabhyam, differences and similarities. In the first instance, it is used to find the roots and quadratic equation 7 into 2 minus 11x minus 7 is equal to 0. Swamiji called the application at the point is as always follows. Now by calculation formula, we say 14x minus 11 is equal to plus root 371. Thank you.